All right, welcome back, everyone. Hope those first two videos didn't bore you that much. This is going to be the last video of Chapter 8, and it involves an exciting topic of testing claims about means. So here we go. One sample t-test for mu, which is the population mean. So the ho is going to have mu in there. The ha is going to have mu in there. The test stat, we're going to be using t, just like last chapter with confidence intervals. Means we use t, so x bar minus mu s over radical n. The degree of freedom is sample size minus 1, just like the last chapter, and it's going to be a t-test. T-test in the calculator. All right. 28. Now, I'm not going to do all of these, but I'm just going to remind you how to find these t-critical values. So what's a left tail test? Alpha is 0.05. N is 50, I gotta find the critical value. So left tail test, alpha is 0.05, so put the whole thing right here. N is 50, so degree of freedom is 49. So I need to find that value. So inverse T 0.05, 49 giving us, and what'd you get, Mackenzie? Oh no, close. Negative 1.6765508. You forgot the 8. Always round to the nearest millionth. Well, there we go. Nice. Right tail test, alpha is 0.01. So you put that here. It gave us a degree of freedom. So if that's 0.01, that's 99. So, I mean, you could do inverse t, 0.99 or 0.01, 14, but you just need to make it positive. All right, Matt, put your phone away. So we get, just gotta make it positive, 2.62. Two-tail test, alpha 0.05, well, 0.025, 0.025, so that's inverse t, 0.025, n is 10, so that's a 9. So we get plus and minus 2.26. All right, perfect. Moving on. I don't really think I need to do this because I'm going to kind of do this when I do the p-value, so I'm just going to do one of them. If I want to find the probability t is less than that, well, there's negative 1.76. I need to find that probability. That's t CDF, not norm CDF. And then degree of freedom. So we have 0.0501. Okay. Number 30. Speed limit a county. Nice job. A county is considering raising the speed limit on a road because they claim that the mean speed varies vehicles is greater than 45 miles per hour. A random sample of 25 vehicles has a mean speed of 48, standard deviation of 5.4 at, let's see, this alpha. All right, do we have enough evidence to support the county's claim? All right, let me read that again. Raising the speed limit, they claim the mean speed of the vehicles is greater than 45. Okay, so they claim it's greater than 45, so that's how I know that goes there. That's a right tail test. So it's you could put equal to, or you could put this. All right, right tail test. The test stat, test statistic. T, x bar minus mu S over radical N. Now the X bar they got from the sample. So they tested 25 vehicles, and the 25 vehicles had 48 miles per hour. Is that enough evidence to say that the vehicles are going more than 45? All right, so some sheriff in this county goes, well, I found 25 vehicles, and they were going an average of 48. But is 48 high enough to really start swinging the red flag? We'll find out, because the sheriff needs to have a p-value. Otherwise, his research is useless. Although I'm willing to bet, though, that they're going to be listening to the sheriff because he'll just arrest everybody, but theoretically. 48 minus, that's a 45. Standard deviation right there, 5.4 over radical 25. And why do it? Do it right in the calculator. Stat, test, t-test. All right, so that's the Ho, 45, X bar, 48, S, 5.4, and N, 25. Here we go. Done. All right, so enter. That's a test stat, p-value, and all the other stuff that you knew. All right, sorry. So 2.8 p-value. So it's a right tail test, that's 2.8, so that's the area under the curve that I have to find. So TCDF, 2.8, 99. Degree of freedom is 24, one less. And I don't even have to do that because I'm just going to copy that, 0.005. So conclusion, since P is less than alpha, 0.10, we reject HO. So the sheriff was right. We're rejecting HO. So there's enough evidence to say that they are going faster than 45. So we have convincing. Yeah, otherwise, where do you draw the line? You know, what if I got 47? Can I say it's greater? 46? 45.02, can I still say it's greater? No, there needs to be some sort of cutoff, and that's what the alpha does for us. All right, test a claim using critical values. Well, if I'm going to test a claim using critical values, and it's a right tail test because of greater than, and my alpha is 0.10, I need to find that value. So that's inverse t, 0.10, degree of freedom. And we obviously take the positive one, 1.3. So my test stat, is my test stat in the critical region? See, here's 1.3. Here's the critical region. Here's 2.8. That's my test stat. So yes, it is. Since my T test stat falls in the critical region, reject HO. All right, 31. Travel Association claims the mean daily meal cost for two adults traveling together on vacation in San Francisco is $105. That is a huge lie. There's no way you're going to San Francisco with two adults on vacation and you're spending an average of $105. You're eating at Burger King for breakfast and dinner only. skipping lunch and skipping drinks, just water. Anyways, a random sample of 20 such groups of adults had a mean daily meal cost of 110 with that standard deviation. Is there enough evidence to say or to really reject that claim? So the Travel Association says the mean daily cost is 105. So you either is or it is not based on that verbiage. So the test stat, x bar minus mu, s over radical n, the x bar comes from the sample. 20 people did 110. That's the mu, 105. That's your s. Radical 20. T-test, right to a t-test. So when I go to a t-test, so stat, test, t-test, there's the ho, x bar, s, n, ha. Okay, test stat, p-value, all right. So 2.6. P-value, it's a 2-tail. So find this, times it by 2. 2 times TCDF, 2.6, 9919. Remember degree of freedom. And just copy the calculator's answer, 0.02. All right, so what do I say for the conclusion? Anybody want to conclude it? Carson, Kelly, Donovan, what'd you get? The P is high. Don't reject the ho. Yeah, very good. All right, conclusion. You know how boring this is for me? Nobody's raising their hand. I have an audience of 0. Since P is greater than alpha, we fail to reject HO. So there's no evidence to support. Well, all right, the way the question's worded, is there enough evidence to reject the claim? Well, no, we're not rejecting it because we're keeping it. So there's not enough evidence to reject the claim. So I guess we could word it like that. That the mean daily meals are 105. So it looks like the travel agency was right based on that data. Let's not do that, we already did that. Let's do the confidence interval. So a 99% confidence interval. That could be the corona. So we get this. Just kidding. We got to do inverse T here. We have to find the critical values. So that's inverse T, 0.005. Degree of freedom, 1 less than n, so 19. And we get T star to be 2.86, plus or minus in this case. So a confidence interval formula is this from last chapter. The x bar we know to be 110. I'm going to use that critical value. The S is still 8.5, and that's still radical 20. And then I'm going to do T interval. Same data's in there. And then, yeah, 99. 104.6, 115.4. Does Ho fall in here? What's Ho? 105. Is 105 in here? Yes, it is. If it's in there, you don't reject Ho. So since Ho, mu equals 105, is in the interval, we fail to reject HO. Same conclusion. So if Ho falls in the range of plausible values, it's good. All right. Now for something like number 32, I'm not going to do it, but I don't give you an X bar and I do not give you an S. You would have to put these in the calculator. Now I'm going to do this super quick. You're going to watch my lightning speed on the calculator. And then you go to t-test. But data, the data that we have is from L1, but we need a Ho. Okay, so you receive a brochure from a large university. The brochure indicates the mean class size is fewer than 32. So that's your Ho, 32. The data's in L1, and you want to choose that. So the X bar is 30.17, the S is 4.00. But notice the calculator gives you S. It knows to give you S. Because if you were to just first var stats this thing, it has S and it has sigma. Well, we're not using sigma. We're using S only with this stuff. I don't know the population standard deviation. I just know the sample of these 18 classes. (33) 50 earthquake depths taken from an online data source, and the summary statistics are as follows. Minitab is just another stat software. So out of these 50 earthquakes, I had an average of 9.81, standard deviation of 5-ish, and then use a 0.01 significance level to test the claim of a seismologist that these earthquakes are from a population with a mean depth of 110, or 10. So it's either 10 or it's not 10. My test stat is this, the T. That's my p-value. My p-value is pretty high because it's close to 0, that test stat. That's my confidence interval. Standard error of the mean is this. So whatever that is, this over that is 709. The standard deviation is S. The mean is X bar. Mu is 10 versus mu is not 10. That's the Ho, that's the Ha. So since p-value greater than any alpha on the planet, we fail to reject HO. So it appears to be 10, because I'm keeping HO. All right, folks, we got through all of chapter 8. So go through these notes, look them over again, try them at your own pace, look at some of the examples in the textbook, and then make sure you guys shoot me a text or an email, or you can call me if you want to, if you need any help with this stuff. And I know I already gave you the cell, but That's it. So, all right, guys.